Now let's go on to metric conversions. Last time we dealt with imperial conversions, things like 60 seconds in a minute, 24 hours in a day. Metric units are all base 10, so that makes our lives a little bit easier. First, let's talk about the prefixes themselves. We have several that are commonly used. The prefix kilo literally means 1,000. The prefix centi literally means 1/100th. Milli means 1/1000th. Micro means 1/1,000,000th. And nano, is 10 to the -9th. So they do get smaller as we go on down. And these are what the prefixes literally mean. You may have seen these done as a number line. I prefer to write them as equivalent statements, which I will show you here in just a moment. Any of these prefixes can be put on any of the metric units. So grams, liters, meters, those are the most common. So I prefer to write these, again, as equivalent statements. We'll use meters just for the sake of argument, but these same prefixes, again, can be applied to grams, liters, whatever the case may be. So 1 kilometer. Remember, kilo literally meant 1,000. So if I replace the prefix with the number that it means, this is the same thing as 1,000 meters. From there, we start getting smaller. So 1 centimeter literally means 1/100th of a meter. Now that's kind of icky. I don't know about you, but I hate using negative exponents. So if 1 centimeter is 1/100th of a meter, I can flip that around. 1 meter contains 100 centimeters. And this is the version that I usually use in my chemistry classes. If we proceed onwards, 1 millimeter is 1/1000th of a meter. Same deal. We can flip that around so that 1 meter contains 1,000 millimeters. Next one on our list was micro. 1 micrometer is 1/1,000,000th of a meter, or 1 meter contains 1,000,000 micrometers. Hopefully this isn't confusing you too badly. Let's do a quick example just to clarify. If I want to take kilometers to centimeters, and again, you can use any of the different ways that I wrote these conversion factors. Personally, I hate negative exponents, so I tend to avoid them at all costs. Another piece of advice I can grant would be to always go to your base unit. It's the easiest way to avoid silly math mistakes. So, for example, on this one, my base unit is meters. So I'm going to, my first conversion factor is going to be from kilometers to meters. Again, if you can subtract exponents and you can jump straight from kilometers to centimeters, more power to you. I find that if you go to the base unit, you make fewer mistakes. So from here, I need to go from meters to centimeters. Since centi means 1/100th, again, 1 centimeter is 1/100th of a meter, means I need 100 of them to make 1 meter. I have my starting unit, I have my ending unit, I'm good to set up my boxes. This is my 1, nothing interesting goes there. I don't want kilometers, I want them to cancel out. So, kilometers on top here, they need to appear on bottom down there. Kilometers on bottom, my equivalent must be on top, 1,000 meters. Kilometers top and bottom cancel. I've used both pieces of my conversion factor. Onwards we proceed. Meters, don't want them either. Means I need them on the bottom to cancel next. 1 meter. On the top goes 100 centimeters. Meters cancel, leaves me with centimeters. Good thing too, since that was what I was looking for. Multiply all the way across the top. So 3 times 100 times 1,000. All the way across the bottom, multiplication gives us 1. So this is 300,000 centimeters. If we like, we can put this in scientific notation. 1, 2, 3, 4, 5. Or we can replace that times 10 to the with the E. So, you could have also used the conversion factor here. Instead of 1 meter equals 100 centimeters, we could have replaced that with 1 centimeter equals 10 to the negative second meters. It is the same truth. It's just a matter of which one you can remember easier, or which one is easier for you to remember. Proper syntax there. Let's try another one. Let's do grams this time. So let's go from 3 times 10 to the 5th, sure, nanograms, and let's take those to milligrams. Again, I highly recommend that you go from your starting unit to your base unit. It just eliminates a lot of simple mathematical errors. So, nanograms to grams. Nano means 10 to the negative 9th. Similarly, you could also say that 1 nanogram is 10 to the negative 9th grams. That also will work fine in this conversion. I just hate negative exponents. So, starting unit present. Now we need to get to our ending unit. Oops, that's micro, not milli. (1,000 milligrams per 1 gram). Again, you could say 1 milligram is 10 to the negative 3rd grams. Just don't like negative exponents. Starting unit present, ending unit present. We're good to set up our boxes. 3.67 times 10 to the 5th nanograms. Smiley face there, since it's nothing terribly interesting. Nanograms on the top, they also must be on the bottom to get them to cancel. Grams go on the top, the other half of my conversion factor. Onwards we proceed. Grams, don't want them either. 1 gram on the bottom here. 1,000 milligrams on the top. Grams cancel, leaves me with milligrams. Huzzah! That's what I was looking for. Multiply all the way across the top. Divided by all the way across the bottom. Divide top by bottom. And we get 3.67 times 10 to the negative 1. If you're keeping it in scientific notation, we don't have to do that. We can always go onwards to the regular decimal form. So long as we have our unit, both are valid answers. If you've already watched the sig fig video, you remember that conversion factors are constants. They do not count in your sig fig tallies. My initial number there, 3.67 times 10 to the 5th, has 3 significant figures, as does my answer. When you're setting up your boxes, please always remember to have a number and a unit in each box. Again, it just tends to alleviate those little small mistakes. As you practice these problems and get faster, then you can start skipping steps. But I highly recommend you write everything out ad nauseum, at least in the beginning. If you have any further questions, please feel free to email me. Again, this video assumes that you have at least been through this once with me or have seen it before, and this is the terminology I use in my classroom. So if your chemistry teacher uses a slightly different terminology, sorry, these are my term-isms. So I hope it helps. Regardless, shoot me an email if you need any more practice problems. Thanks.